No worries. So I believe we are recording now. I'm just going to go through a worked example of Paraview while recording. Again, stop me at any time if you need to. I'm just going to open up a Paraview file and I'm going to show you what I did to get the image shown here. So I'm just going to kind of come out here and go into my Paraview, which is 5.3 in my case. Everyone see that okay? Yeah. So now you have this Paraview screen. And it's got a number of different setups. You have it's kind of like working in Inkscape or some sort of visualization, any sort of visualization software has the same kind of ribbons that you'd have in if you were doing PowerPoint or something like that. What you do to open a file is you'd go to your the file open area. Mine is currently in my documents, UTSC projects, workshop 1. So this should be the file that you had. We're going to look at output continental extension. That is the output folder that's generated when you run a model. And you click on that and you'll see you've got a solution folder. The solution folder has all of the information in that you'll need to visualize your data. So if you click on the solution folder, you will then see kind of 2 separate areas. You've got something that ends in VTU. These ones here end in VTU, and they are the number. They are there's 16 different VTU files. So it goes solution and then a whole lot of zeros. That's the output number. So in this case, 0 means it's the first output. It's the times 0 basically. And then the second dot and then these other zeros are that the code has specified that when we create a visualization output, it's split up into 16 different components. That makes more sense when you're creating huge models in which one output is a gigabyte, because you don't want to then, you might not want to download one file that's a gigabyte. You might want to download 16, which are 1 divided by a gigabyte divided by 16 size. It's a bit of a nicer. If you end up using something like GitHub to store some data, then this sort of thing's really good because GitHub only allows you to use certain file sizes for each file. So in this case, it's split up into 16. So you've got a VTU file, which has all of the different the different components for that one time step. And then here you've got 40 different time steps. Each time step is 1,000,000 years. So you've got 0 and then 40, 40 being 40 million years, you've got 16 for them. However, we don't actually use any of them for this. We are looking at these PVTU files, which combine all of the different VTU files into one. So PVTU is a combination of the VTU files, so you don't have to individually load in millions of files. So 16 times 40, you don't have to do that. So a PTU file, if you just double click on this at the top, you'll be able to open it. So it automatically loads in. So there you have, it says solution, and then it's got an asterisk there. That means there's not just one file, there's 40 of them. You could just look at one file if you wanted to. You would just do this and click on one file, and it would just be one there. But for us, what we're going to do is we're going to look at 40 in one go. It's really good for 2D, really good for 2D because you can load in many at a time and you can maybe create videos and things like that. For 3D, it tends to slow down your computer a touch. So first, we've clicked on that. At the bottom here, it says apply. That means we start to load in these files. We have a question. And 40 is a minimum, you said, right? Was it something? No, 40, yeah. So 40 is for, it's just a, sorry, actually the question is that, yeah, 40 is a minimum. It's actually, this is just the the model happens to run for 40 million years. So yeah, it's not related to the actual time. So that was slightly confusing. So before you click apply to load all these this information in, there's a bit below which tells you all the different parameters that are stored in that PVTU file. So in that PVTU file, you've got information about the velocity of the model, the pressure, the temperature, the upper crust, the lower crust, the mantle, that seed I was talking about, the density of the whole material, of the whole model, viscosity, strain rate, which is what you're looking for, and an error indicator as well. If you don't want to load all these things in, you can check them and things like that, but we can just press apply and that'll all load in. So once you've pressed apply, you'll be able to see a nice gray box. That gray box is 100 kilometers depth and 400 kilometers across, like I described before. So now you've got a gray box. That doesn't really mean anything. If you see at the top here, it's at time 0, which is the first time step. So this area here, it says solid color. That is what's being shown here. That is your parameter space. That's your parameter file. Your solid color is just gray at the moment. However, if you click on that, you'll start to see all the different parameters that were mentioned, that I just mentioned below. So you've loaded in temperature, density, lower crust, upper mantle, lower crust, mantle, pressure, seed, strain rate, upper velocity, and viscosity. So now you have all of these in, ready to go. Let's have a think about, we've got 100 kilometers depth. The upper crust is about the top 20 kilometers. So we click on upper, you will see that you have now, it's now changed from gray to red and blue. The red here is, as this legend shows, red is value of 1 for the upper crust, and 0 is this blue. So the upper crust is 1 here, and 0 below it. So the top 20 kilometers is upper crust. You just change it to lower crust, you will see the bit below that. There's 10 kilometers there is lower crust, and you change it to mantle. There you go, the bottom bit. So there you got your 3. Density, let's have a look at density. It's probably going to change this legend slightly. So now you've got the density, you've got 3 different layers there. You've got a lower density upper crust, and then a higher density mantle lithosphere below. So you can start to see the differences just by applying this. Now let's look at this density, because it's actually it's got 3 different colors in there that you can start to see over time. So we've loaded in 40 different time steps. So if we press this play button, we should be able to go from our initial condition, which is this, and we'll be able to go all the way to 40 to see what happens as we pull this by whatever it is, a centimeter per year. So if we press play, we can start to see here that you're starting to see a rift forming. You've got to see this topography that we mentioned, and we've generated actually material coming up, and it goes over to 40. Very simple. This model actually took 9 minutes to run on 40 processors. So very simple. You can go and put the kettle on, come back, and you've got yourself a little model. So cool. Ah, yes, very good. This is just the tip of the iceberg. Yeah, so that is a simple model, but I'm showing you this because it's actually that. I mean, this is density. This is your thing of density. You kind of want to start to play with this sort of stuff to see different values. So you can, if you just look at the mantle, yeah, you get to see the mantle there. You get to see this blue. You can start to play around with it. What I generally do is I load in more than one solution. So let's just flick this back to the start. We have this solution here, but actually generally load in this exact same thing again and apply, especially for 2D models. Now I've got 2 solutions at the same time. So that's that means I can start to play around with layering up this this model. So let's just take this one for now. So see this eye here, you can get rid of, that means it's visible. If you turn the eye off, it means it's not visible anymore. So let's just have a look at this solution here. So what I want to do is I want to recreate the image that I did before. So I had upper crust before, shown here, red being the upper crust. If you see this little area here, it says edit color map. We can click on this and it'll come up with a new section in which you can start to play around the different colors. This heart says choose preset. So what you can do is you've got a number of different preset color maps that you can use. I've loaded in a couple of my own as well at the bottom, which you can load in quite easily. I forget what the color scheme was now. What did I choose? Oh, dark red. There you go. Dark red. So that must have been this. Must have been cool to warm extended. Looks about right, doesn't it? Looks about right. However, that's not very useful. So what I use is enable opacity for mapping of surfaces. So what I've done is I've actually just got rid of anything that isn't upper crust. So now I've just got a little floating upper crust here. What I'm going to do now is bring back that other solution. So now I've got underneath that, I've got my another solution, which is just currently on solid color. So what I can do is maybe do lower crust and add that in. So now I've got this dark red, this other red, and this blue. Now I can't remember what color scheme I used. Okay, that. Let's see. I can go and click on this again, the presets, and maybe try another scheme. Was it this? Look, this looks familiar. Apply that. Yeah, that looks really familiar, doesn't it? So now I've got this lower crust is now this color, and anything that isn't lower crust is now this kind of teal color, which is similar to what I had before. So just by loading in 2 and using a bit the opacity, I've now created what I'd shown you before. You can get rid of these legends for now if you wanted to by clicking on this legend tab, legend visibility. So now, yeah, that's similar. That is similar to what we had before, isn't it? So this is what we had before. Let's have a look. We can just run this model in Paraview. The problem is everything's at the top. Yeah, so great. So now we start to run this model over time, and we've got upper crust, lower crust, and the mantle lithosphere, and we start to see a bit more features than we did before with the density. And you can start to see how it evolves, and you can start to see a few different other things. See some things creeping in behind where the lower crust is deforming, where the upper crust is deforming. So now I've created that image in what 2-3 minutes just by loading in a few different things, and you've created a video. You can go onto Paraview and you can go and save screenshot if you want to be. That'll give you a snapshot of that. Save animation, which you can click on. It'll give you a frame rate, 15 frames per second. Is that mega fast? Let's do 10 frames per second, starting at 1 resolution. Yeah, time step, save animation. Let's save it in workshop 1. Animation 1, you can click on type of files. Actually, if you click on JPEG, it'll just give you 41 different JPEG files. But if you create AVI, it will create a movie for you. So it'll run through that and create it. Do we adjust frame rate for different animations? So the frame rate, there's only 41 frames in that. So 15 frames per second is going to give you a very short video of 1 or 2 seconds. I've changed it to 10, so it's going to be at least 4 seconds. But now that is currently saving the animation. It should be animation 1. So now we have a 4-second animation here, which is exactly what we've created. So in what, 5 minutes, we've managed to load in some material and create an animation of the day that we have. That is just the tip of the iceberg of what Paraview can do. You can start to play around with clipping things, so you can only show half of data. You can what's one of my favorites? Plot over line, so you can create a line. Let's just move the line to here, and it will be able to plot some information about this line. What do we want? Should we do viscosity? Let's do viscosity. No, let's plot density. So you can see in the middle of the kind of left flank, you've got density increasing from 0 to 1000. 0 is the bottom of the box, so it's actually the base of the model, and 100,000 is 100,000 meters, I think, in standard SI units. That's the top of the box. So it starts off with low viscosity in the upper crust, and then lower crust, and then it goes all the way down to the mantle lithosphere here, the higher density stuff. So there's lots of things you can do, but to get you started, like I just showed you how to load things in, and how to hopefully get started on plotting things, plotting information. Any questions before I stop sharing, stop recording? Is there a chart that tells you which range you're aiming for? Oh, in terms of animations? No, I mean, you can just play around with it. The video that I created there is pretty fast. You can play with that in terms of frame rates as much as you want. You can make it last forever if you wanted to. But yeah, that's all good. All right, I'll stop sharing. I'll stop recording now, and I'll post this online so you can watch it at your leisure.